So in this case, we want to find out what is the proper join to utilize. So far, the examples that we've seen are made up of single entry, single exit blocks. But in this example, we have an AND split, and then in one of the two parallel branches, the one that starts with activity B, we have an XOR split that allows us to get out of that particular branch by executing activity E instead of activity D. So now, if in place of the question mark join, we put an AND join, we have a problem, because the AND join will want to synchronize behavior coming from both the two incoming parallel branches. However, we know that it is possible to get out of the top branch by performing E after the XOR split rather than D. In which case, the AND join will wait for a token that will never arrive from the top branch. Hence, this is a deadlock, meaning that the process systems will get stuck in this particular point, unable to proceed any further. Now, if we replace the question mark with an XOR join, we see that we have another problem. This solution will be undeterministic. In fact, the XOR join will always receive a token from the bottom branch, but may or may not receive a token from the top branch, the one starting with activity B. If we execute activity D, then we know that a second token is going to come to the XOR join from the top branch. Otherwise, if we execute activity E, that token will never arrive. As a result, we may execute activity F either once or two times, which is an undeterministic behavior and may not be desirable. So now it is clear that in this case we need to use an OR join. So we have to match the AND split with the OR join. We need to use the OR join because we know that this construct waits for all incoming active branches to complete. So once the AND split is executed, it will send one token to the top branch and another token to the bottom branch. The OR join knows that the bottom branch at that point is active. There's a token, the branch is actually being performed. Eventually that token will arrive at the doorstep of the OR join through the bottom branch. However, after the AND split has sent one token up to the top branch, until that point the OR join doesn't know whether that branch is active. Because yes, there's a token flowing through B, but that token may get out of that branch if the XOR split sends the token to activity E. So the OR join will wait until that decision is taken at the XOR split. If the token is sent to activity E, then the OR join will fire as soon as it receives a token from the bottom branch. Will send that token out. But if activity D will be executed, then the OR join will have to wait for both tokens to arrive. And then at that point, synchronize the two tokens, acting as the AND join, and sending again only one token out to activity F. So if we use the OR join, we are sure that activity F will only be performed once.